All right, welcome, ladies and gentlemen. My name is Brian McLogan, and this is week 15 open Q&A. So I had some questions that have been submitted to my channel ahead of this live stream that I am going to cover. So sometimes students will go ahead and actually send me the examples. So sorry about that. And then sometimes they just want me to go through some topics. So I always ask, the more specific I can get, the easier it is for me to kind of pick up some problems, but sometimes I just, I don't have anything, so I just figure, well, I'll go ahead and cover it. So let's see what's on the docket here. We have simplify radical expressions. I'm going to make up some problems here. Hopefully that will be helpful. I will cover just kind of like the general idea of graphing logarithmic functions. We'll talk about solving quadratic equations. I'm really going to kind of focus here on factoring as well as I'm going to focus here on factoring and using the quadratic formula. And then we're going to talk about how to write the equation of a perpendicular line, given like another equation. And then we'll simplify logarithms. So that is what we're going to kind of cover, at least so far. We'll kind of see how the live stream goes. Oh, well, thank you very much, Polynomials Algebra. I appreciate the... did you watch Mr. V's new video? I didn't see his most recent new video, but I did see the one, the team trees, which I believe last time I checked, they were up to 16 million. So I did it, but thank you so much for the super chat. That is very awesome of you. And I'm glad that so far my content is helping. I look forward to hopefully be able to get to answer some questions here that will help you out. I don't know why this didn't. This is going to be so annoying. Every single time I get that super chat, it keeps on popping up on my screen, and I can't figure that out. But either way, but yeah, so guys, if we have a little bit more time, probably roughly try to plan on going, around 35 minutes here. And, if we have some other time, then I'll be more than happy to answer, whatever questions I feel like I can kind of cover within that time period. So as you're kind of going through the live stream or as you guys are joining on, if you do have any questions you'd like me to cover, I will try to do my best to get back through the stream. But also, you never know. It might not be myself that will be answering the question, but, there's a lot of really, really smart people that join on these live streams that hopefully can help you out. And, sometimes maybe they can't answer your questions directly, but maybe they can lead you to another direction. So, if you have some questions, let me know, put them in the chat, and, either myself will cover it over on this live stream, or hopefully maybe somebody else can help you guys out. So, all right, guys, seeing you guys join on in. That's awesome. Harsh, Chris, you guys getting in. Vic, very good to see you guys. Briggs, Hyro, Pori, Sandy, Gracie, very nice to see you guys. Good little group. Sounds fun. You guys joining on. That's very, very helpful. But yeah, guys, again, I will try to get to the questions. Like I said at the beginning, I already have 5 of them up there, so it doesn't really matter how many times you type your question. I'm going to get through these 5 examples first, and then if there are some questions, I will ask for some open Q&A. So, for right now, if you have a question, just kind of, plop it out there. And then most of the stuff, obviously, if you've been following my channel, you're probably in somewhere between the Algebra 1 and Calculus. A lot of the stuff I already have videos on or playlists with multiple videos on. But again, I know obviously the reason why I do these Q&As is because sometimes, you just kind of need like a quick little fix or a quick little summary to help you out rather than kind of searching through multiple different videos, because obviously I have videos that are really, really old and maybe my explanations might not be as on point, or they're topics that I haven't, taught in a while. So therefore it might be something you'd have to kind of, I'd probably maybe the way I teach it now would be a little bit different than maybe how I taught it back in the day. The only other thing I wanted to let you guys know about is for those of you that are in, calculus, pre-calculus, algebra 2, college algebra, I will be making a video on Tuesday, I believe. Or actually, maybe I'll send it out on Monday. Either way, take a look at my channel. If that's something that you're looking for a review, I will make sure. I think I'm actually, yeah, we'll see. We'll see how. I think I have a couple more things to do to get it worked out. So maybe on Tuesday might be the best idea. But either way, either Monday or Tuesday, I will be presenting out my review for my semester exam. I made the semester exam video last year, so therefore I'll obviously link to that video, which actually goes through the answers. But I will at least have that available for you guys. So therefore you have, I think it's like 45 questions that can help you work through your exam review. And then also have some extra problems for each of the chapters that I provide for my students as well. So if you are taking a semester exam in one of those courses, I think you'll benefit. It's obviously free. It's just, something I wanted to offer to you guys. So hopefully that is something to help out. But yeah, just make sure you're following my channel, at least my uploads for this week, and I will have that available for you guys. All right. So before we get started, just want to kind of check to see. I know. Oh, man. That's so annoying. I'm just trying to see if ours. All right. Okay, so let's go ahead and get started with this, guys. And again, for those of you that are adding on to the stream, after I'm done with these questions, I will come back in, say hi to those of you that are joining in, and then what I'll do is I'll maybe answer any questions. So I know some of you might be, having some questions, put them out there. If I'm not able to get to them, which is probably highly likely, then hopefully somebody in the chat, though, can maybe answer some questions. And again, if you kind of can help somebody, please help them out. I mean, a lot of people are here because they have like some kind of quick question, or they're, they want to know where to go for those resources. With my channel, other channels, online calculators, websites, whatever, if you know a direction that can be beneficial to somebody, please help them out. So therefore, they can get the help they need, because again, like that's what we want to do. We want to get to our, we want to get our help as quickly as possible. But for the people that submitted some questions to me earlier, I want to make sure I get to them. And I've been talking about 7 minutes now, so let's go ahead and do some math. All right, so I'm just going to make up some radical expressions just to kind of, break things out, or just kind of, work through some things. So I think to understand radical expressions, first we just need to understand like what is actually the square root, representing here. Well, I'm just going to deal with square roots just to keep things, kind of simple. So if I had like the square root of 9, again, that is basically asking us, what number multiplied by itself is going to give us 9. And therefore we can say that answer is going to be 3. And again, because 3 times 3 equals 9. And one thing, actually, another way that we could write this when we're like first learning this, we would write this as 3 times 3, right? The square root of 3 times 3, you can see 3 is being multiplied by itself. This gets to equal 3. Well, so that becomes the same thing as like, x squared. That's just going to be x, because again, that same understanding that x times x is going to equal x. So that's really the idea when we're at least looking at the square root. And the cube root would be multiplying by itself, twice, 3 times 3 times 3, or x times x times x. Same kind of idea, just going up as that index, as the index, gets higher and higher. So now the kind of question is, and again, this is where it comes into hard, because I would explain this differently from algebra 1 to algebra 2 to like pre-calculus, what to do. But I'm just going to kind of make up some problems here and just kind of go from this idea of how we'd want to simplify it. So these are fairly basic. And my idea is when you're looking for the square root, you're looking for numbers that you can easily take the, the square root of. So for instance, you have the square root of, or 9, like think of square numbers like 9, 4, 25, 36, 49, keeps on going all the way up. Those are numbers that they can be you can take the square root of them. So what if you have like a number like 18, and let's do x cubed, okay? So if I want to simplify this, what I'm really looking for is I'm looking to break this up into square numbers. So a lot of times people will look at this and say, oh, well, you can break up 18 as 6 times 3, right? And yeah, you can break that up into 6 times 3, but 6 times 3, you can't take the square root of 6, nor can you take the square root of 3. However, we can rewrite this as 9 times 2 times x squared times x. okay? So what the nice thing about this, and again, just follow me with this, that 9 times 2 times x squared times x, like 9 times 2 is 18, x squared times x is going to be x cubed. Now, the rules of radicals, what this allows us to do is we can actually now break this up into the square root of 9 times the square root of 2 times the square root of x squared times the square root of x. Okay, so again, like remember when you multiply radicals, as long as the index is the same and the radicand, then you just multiply the radicands under, like 9, square root of 9 times square root of 2 is going to be square root of 9 times 2. So I can break this up here. Well, again, now you can see here, this is just going to turn into a 3 times the square root of 2. Square root of x squared, we already know is times x times the square root of x. Now again, since again our index here is square root of 2, or square root of 2 and x, we can multiply those, and then we multiply our arguments on the outside, 3 and x. So I get a 3x times square root of 2x. So that's the basic idea. I'm actually not going to go into a third example because I kind of explain that kind of more in detail. So hopefully that kind of helps as far as the idea, because you can do cube roots, fourth roots, a little bit more different variables. But that's the general idea. What I always like to do is try to break up whatever number you have, because then this is a square root, into square numbers. And if it's the cube root, then into cube numbers. And you can do that with variables as well, doing that same kind of idea. So when you're doing with variables, you're kind of looking and breaking it down using the rules of exponents. All right, so graphing logarithmic functions, I don't know why that's, I guess it's F's. I guess I forgot the T. It's kind of a weird T that I did there, but I'm going to leave it because I think it kind of looks cool. All right, so to understand graphing, I think really just kind of understands, you got to know the parent graph and you got to understand transformations. And this is something that we've kind of talked about in my class because right now we're at the trigonometric functions part. So we're dealing with graphing sines and cosines, tangents. Our last lesson was graphing cosecant, secant, and cotangents. And really what I just explained to students was you just have to know your transformations. I mean, obviously you have to know the graph, but as long as you understand like the general shape of the graph, and then the transformations, you can sketch the graph. I don't teach graphing as detailed as I used to. I used to spend a lot of time with the graphs of the trigonometric functions. And I just realized it wasn't really good use of our time, really, because one, it's difficult for students to do it in class. Like it's hard and it takes a while. And then also, I really don't need them to know a lot of this, a lot of that stuff, especially once, teaching calculus and stuff, they need to understand some of the, characteristics and what the general graph looks like. But besides that, I was like, all right, that's cool. So that's kind of what I kind of go from there. So, or what we do at least from that point. And I kind of take that on, same thing with logarithms as well. Like you should understand the parent graph. And again, this is the natural logarithm. But it doesn't really matter if it's natural logarithm or if it's, log base 10 or 5. Like it's going to have this general graph, right? Now, again, there's one point that's very important, which is 1, 0, which ends up being our x-intercept. The graph does not have a y-intercept. And you can see there's actually a vertical asymptote along the y-axis. And that is why it doesn't cross the y-intercept or y-axis. So there's why there's no y-intercept. But here's the graph. And then, now again, obviously this is with no transformations, right? This is the parent graph. So if I had, y equals a times ln of b times x minus c plus d. All right. So again, just remember a is going to be stretching or compressing the graph, vertically stretching or compressing the graph, as well as reflecting about the x-axis. B is going to be horizontally stretching or compressing the graph, as well as reflecting about the y-axis. C is shifting the graph left or right, and D is shifting the graph up or down. Something that we have done, when you're getting to logarithms, you have already done this for quadratics, you've already done this for radicals. At least I assume, I guess. I already done this for exponential typically. So it's really the same thing over and over again. It's just the function is really different and the graph is different. So I'll just do kind of like one example. For instance, if I had y equals -2 ln of x plus 1 minus 3. So Again, there's kind of two parts of this. And again, this isn't like a very advanced one, but there's kind of two things. These are my outside functions, right? So again, if you have a transformation that's outside the function, that is going to be impacting the graph vertically, right? This is actually going to be a vertical stretch. So I'm taking this graph vertically, stretching it, and then the negative reflects it. And then the graph is being shifted down 3. So here's my original graph, right? It got reflected, so now it's going to go like this. It's being stretched, so it's going to go a little bit farther. And then it's going to be down 3. So shift that down 3, that would look something like that. But again, like notice, it's very important to understand, like when I shift this down 3, like the graph looks something like this. Like that was the y-intercept, right? That was my old point 1, 0. Then it just got shifted down 3. Like the stretch and the reflection did not actually change that point. Then what we have is now the graph is actually being x plus 1. That's going to shift it to the left one. So that means the asymptote now is actually going to be changed. Instead of the asymptote at y equals 0, now it's going to be over here. And I'd probably need a calculator here to calculate where the y-intercept would be. But we can see from on there. So roughly that's what the graph would kind of look like. But you do recognize that now they would have a y-intercept at 0, 3. Another super chat. Thank you so much for polynomials algebra. The proofs of AA, sine, angle, side, and side, side, side. Well, thank you so much for the super chat. I'm not really sure what you need me to cover as far as the proofs. Again, I don't have any proofs memorized. I can talk a little bit more about side, 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 angle, side, like how they can be helpful and used. But if you have maybe a little more information or maybe a problem that you'd like me to kind of cover, just kind of let me know and I'll be more than happy to do it because I do appreciate you putting in the little extra for the super chat. But I will try to come back to that at the end for that. So, but thank you very much for that super chat. And then if there's anything else I can kind of like add onto those two theorems, because basically they prove congruency, so I can kind of explain them a little bit more. But if there's anything else that you kind of need me to elaborate on, let me know. All right, so solve quadratic equations. So I'm just going to kind of like work my way up. I'm just going to make up some problems, and I just want to kind of explain some things because there's some very, very common issues that I have seen a lot that's been working on. So we have ax squared plus bx plus c. Okay, so let's do x squared minus 5 equals 0. Let's do x squared. You know what? Let's do, I'm just going to make this factorable. You could do 5, but I'll try to keep things fairly basic. Let's do minus 4 minus 4x plus 3 equals 0. And then let's do x squared minus 4x minus 3 equals 0. Oh, actually, you know what? Let's change this. Let's have some fun. Equals plus 3 equals 3. There we go. Perfect. All right. So when we're solving quadratic equations, now actually I should probably even add one more here. So just the other equation, well, yeah, let's just do a quick little like 2x minus 1 equals 5. Okay, so if I said to solve this, right, that's a linear equation. Now again, for the linear equations, when you learned how to solve, you isolated the variable, right? So we add a 1 to both sides, and then we'd have 2x equal to 6, then you divide by 2 on both sides, and x equals 3. Right? So that was our solve. That was using our inverse operations. So the problem is a lot of students always want to solve quadratic equations just like they solve linear. Well, sometimes that works, but majority of the time it does not work. And let me explain. You could solve this using inverse operations. This is x squared minus 4 equals 0. Now, the reason why you can solve this like a linear equation by using your inverse operations is because there's only one variable. Now that variable is raised to the second power, which tells us it's a quadratic. But since there's only one of them, you can just isolate the variable using inverse operations. So you could just add a 4 to both sides. And then the inverse operation of squaring would be the square root. But again, it's the plus or minus of that square root. Right? It's actually inverse operation is plus or minus the square root. So therefore your answers are x equals plus or minus 2. Again, notice for a linear equation, we had that one answer. For quadratics, we have 2 answers. Now again, that's not always going to be 2 answers, but the maximum number that we learned in polynomials would be, or in our chapter of polynomials, is going to be 2. Now again, we could also factor this, right? And that's what I'm going to do next here. Now it's really nice that this is equal to 0 because, and that's one of our key components that when we're solving quadratics, obviously if we're using the inverse operation, just get it to the other side and solve it. Like you only have one variable, that's good. But if you cannot use, or if you're going to use factoring or quadratic formula, you want to equal to 0. For factoring, we want to equal to 0 because we want to use the zero product property. And again, the zero product property states if you have a product equal to 0, then one of those products has to equal 0. So x equals 2 and x equals negative 2, which is exactly what we got here. So in this next example, again, I want to see like factoring. Now again, this is like a trinomial, and again, to kind of keep things rather short here, I'm not going to explain in depth the quadratic factoring. We basically are looking for what two numbers multiply to give me a positive 3, add to give me a negative 4. Thankfully, there's only some numbers that multiply to give me a positive 3 that add to give me a negative 4, and that's only one, negative 3 and negative 1. Now I have a product equal to 0, so I can just apply the zero product property, and I get my answers very nicely. Now, the biggest mistake here, and the reason why I changed this, is because students say, oh, well, let's just square root, or let's add the 4x and then take the square root. And I say, no, you have two variables. You have an x squared and x, right? You have a quadratic and a linear variable. They are not like terms. You can't combine them. You can't use inverse operations. You can only use inverse operations when you only have one variable. So in this case, what we need to do is we need to set it equal to 0 to look to factor it. And unfortunately, this is non-factorable because the only two numbers that multiply to give me negative 3 are going to be negative 3 and positive 1, or negative 1 and positive 3, and neither of those add up to a negative 4. So when I have a quadratic, ax squared plus bx plus c equal to 0, I can use the quadratic formula. So the quadratic formula says the solutions to a quadratic are going to be opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So again, like we're trying to solve for x, right? The solutions, the values of x that make that equation true. So therefore, I can say my a is 1, my b is negative 4. So when we're doing the quadratic formula, when we're first learning this, I like to just list them. And now we're just going to plug those numbers into the quadratic formula. So the opposite of negative 4 is positive 4, plus or minus b squared, which is 16, minus, let's see, a 4 times a times c. So 4 times a times c is going to be a negative 12, divided by 2 times a, which is 2. All right, and then we simplify the radicand. That's going to be, what, a 28? Then, using what we learned in previous, we can see what square number divides into 28. Well, I know 4 does. 4 goes in there 7 times, right? So I can take the square root of 4, which would be 2. So this would be 4 plus or minus 2 radical 7. And again, for those of you that are not following along, that's 4 times 7. Square root of 4 is 2 radical 7. And that's over 2. And then you can divide the 2 into both of those. So therefore, I'd have 2 plus or minus the square root of 7. So that is what x is going to equal. So x equals plus or minus the square root of 7. So again, just solving quadratics. I mean, typically the fastest, the easiest thing to do is looking to factoring. That's why I think it's so important to really be strong with factoring. However, if you only have one variable, you can use inverse operations. Obviously, if something's non-factorable, then you could use the quadratic formula. You could also do completing the square. But I think for most students, quadratic formula is going to be preferred. All right, we only got 2 more, guys, and then I'll maybe maybe kind of see if I can add in some questions. I will kind of talk about let's get onto that congruency I think side, and angle, or not angle, that's, and then side. All right, I will talk about those, and then maybe if you guys have some questions, anything else, maybe some quick ones, I can kind of add those at the end. All right, so I'm just going to kind of work through an example here. I don't really have time to kind of get in depth through this, but I'll just kind of go through the basic process here. So let's pretend I have an equation. So y equals a negative 3/5 x plus 1. And I'm making up a problem. Let's find the angle that is going to be perpendicular to that. So really the main thing that we need to understand for whatever graph that whatever my line, like here's my original line. If I want to find a perpendicular line, the one important thing you need to know, if they have parallel lines, they never touch, so it's exactly the same slope. Perpendicular lines have what we call the opposite reciprocal slopes. So that's going to be 5/3 x. And then, but we don't know what the y-intercept. Oh, it has to be going through a point. Shoot. Let's do 0, 1. Sorry, I'm just going to keep this rather simple. So we know this new line, if it's going to be perpendicular, it has to be y equals 5/3 x plus b. So typically when we're doing the problems like this, and again, it's been a really long time since I did these, you're given a line, and then it says, find me a perpendicular line that goes through this point that's perpendicular to this. So really the main thing is we know it has to go through this point, which again on a coordinate grid represents an x and y coordinate, and it has to be perpendicular, meaning it has the opposite reciprocal slope. So you could use the slope-intercept formula, or particularly you can use the point-slope form to be able to find this new equation. So particularly to use the point-slope form, which would be y minus y1 equals m times x minus x1. Now, these are technically, x, they could use x and y, but typically we like to use these as x1 and y1. This represents the point on the graph, and we know our new slope of this new line that we're trying to find is going to be 5/3, right? Because if the original line is negative 3/5, the perpendicular line is going to be opposite reciprocal. And again, I'm, just generalizing some things as far as those are what you need to know from that. So now let's just plug in these points. So y minus 1 equals 5/3 times x minus 0. Well, x minus 0 is easy, right? That's just going to be x, and then we'll add 1. So y equals 5/3 x, and then add the 1 to the other side equals plus 1. So there you go. That's at least the general idea. Hopefully that at least helped you out. Obviously, I just tried to make things simple because I had to make it up on the fly, but hopefully that helped out. All right, so for question number 5, I was kind of thinking about a couple different ways we could do this. And, one way would be using the properties of logarithms. So by using the properties of logarithms, when we have division, we can break this up into log base 4 of square root of 8 minus log base 4 of 2. And remember that square root can be rewritten as to the 1/2 power. So therefore that can also be written as 1/2 log base 4 of 8 minus log base 4 of 2. Now again, to evaluate these, we basically got to ask ourselves our question, like 4 raised to what number equals 8? And 4 raised to what number equals 2? Like that's basically what those logarithms are asking us. And to answer those questions, we can use the properties of, the 1-to-1 property. So we could say 2 squared is 4, right? Times x equals 2 cubed. And again, basically what we're trying to identify here is when we're using the 1-to-1 property of exponents, we're trying to get the same base, right? Because if we want 4x equal to 8 without using a calculator, we need to have them as the same base. So I'm going to rewrite 4 as 2 squared, and I'm going to rewrite 8 as 2 cubed. But remember, that's 4 raised to the x power. So now, using the 1-to-1 property, I can say 2x is equal to 3. So therefore, x equals 3/2. And then here I could say 2xx equals 2 to the first power. That already has a base 2. So therefore 2x equals 1 divided by 2, x equals 1/2. So therefore I have 1/2 times 3/2 minus 1/2. which ends up giving me here, let's see, 3/4 minus, I could change 1/2 into 2/4, which is going to give me 1/4. So I just changed 1/2 into 2/4, so therefore I could subtract those. The other way I was looking into doing this, which I didn't do it, would actually be to simplify the radical, kind of like we talked about. And if you simplify this radical into the square root of 4 times 2, that'd be 2 radical 2 over 2. Those actually simplify out. So therefore, we're just dealing with the log base 4 of 2 to the 1/2 power. Bring the 1/2 in front. And then we have log base 4 of 2. Well, we already did log base 4 of 2, right? That's equal to 1/2. So that would be 1/2 times 1/2, which is equal to 1/4. I'm sorry my work looks really, really sloppy, but hopefully those of you that are following me can kind of take care or understand from there. All right, last question, guys, and then I'll get into some of the questions you guys are doing. So the student asked as far as the side angle side theorem and the side. So I'm not really sure what they are referring to. The only thing that I'm aware of that I remember from my geometry days, which we talk about in my class for pre-calculus, is, understanding when triangles are going to be congruent, meaning they have the same size and shape. So if, obviously angles, right, if I use the same tick marks, if they have the same sides, then that means they obviously are going to have the same angles. So if they have the same size and angles, then those triangles are going to be exactly the same, otherwise known as congruent triangles. So you can't say that the same thing with the angles, though. The angles can be the same and the side lengths not be the same. But once we know that the side lengths are the same, then the angles have to be the same. And since the sides and the angles are exactly the same for both those triangles, they are congruent. So side, side, side proves congruency. However, angle, angle, angle does not prove congruency. But if we have side, angle, side, side, angle, side, side, angle, side. So side, angle, side is also another one that does prove congruency because well, I guess maybe that's what they're looking for is like the constructions as far as with them. I'm trying to think of, man, I don't really remember as far as the proving it from there. It gets to the point is once we start doing the law of sines and we get to the angle side, you can kind of see why that doesn't prove congruency. And I guess like if I was to draw another triangle, like, let's maybe use that converse theorem here. Like, all right, let's just do the side angle side, right? So they have side angle side. Well, there's only 1/3 side I can draw here. Like I have no other options. I can't change this angle. I can't change those sides. So the only side I can do, is right there, right? And again, like the same thing, if I have these triangles, have these all the same, of course it's going to look like those other two. Like there's no other triangle I can draw that would be different that has side, side, side or side angle side. So that's just kind of how that idea, kind of works. Obviously I'm a little way too far removed from geometry class to kind of give you a little bit more of a methodology and working through them, but hopefully at least that explanation is sufficient. All right, so there you go, ladies and gentlemen. I am done. Trigonometry triangles, right? Yes, but these are oblique triangles. Right now we are trigonometry, like our trigonometric functions are just over your sine, cosine, and tangent. So guys, I don't have much time for any kind of questions though, but I do see Johnny and Dragon and Pori and Wolf and Adeline and Allison and Johnny. Good to see you guys have joined on. Thank you so much for staying with me. And I saw you polynomials algebra. Thank you so much. Hopefully that explanation helped you out or explained. I'm not really as familiar with exactly the theorems or what you needed for me or wanted from me, but I really do appreciate that super chat, and hopefully at least my explanation maybe kind of made some sense or had some things click. And Sarah says, how do you know if you can make a side-side angle another AMB triangle? I am not another A and B triangle, I'm not sure, but a side-side angle does also prove congruency. So the only one that does not is, of course, the one that says the bad word, right? The angle side-side does not prove congruency, and that's something that we get into in the law of sines. We talk a lot about that, and we show that as far as why that doesn't work. To use the quadratic formula to find the x-intercepts? Yes, for a quadratic, because the solutions to the equation when your quadratic is equal to 0 are the x-intercepts. So yeah, the quadratic formula is useful for a quadratic equation to find the intercepts or the solutions. Thank you so much. I learned so much. Well, thank you so much. That's awesome. I really appreciate that. Adeline, thank you. Rub your head. Joseph, you got this, my friend. You got this. You know, I actually had a couple students back in the day, I guess when I was like younger and they just thought like more comfortable with me. They'd always like rub my head before a test, like they'd walk in. It was kind of weird, but you just kind of remember like now I'm like a little bit more older and like nobody really wants to like now mess around, you know, with me or stuff like that. But I remember back in my day when I was a nice young teacher, students just kind of thought that was a good luck charm. Dividing polynomials. I'm not sure if I can be able to fit that in. I only have a couple more questions for you. But if you had something specific that you wanted me to do, but just kind of go over the general topic is going to be something that's going to take me a little bit too long for on this because I only really have about 4 minutes left to end it on here. So I apologize. Mr. McLogan, Johnny says, I'm just a bit confused on how to get the domain of f circle g function. I can explain that rather quickly. So it doesn't really matter what the domain is, like when you're trying to identify, or what the functions are. So basically, I mean, well, it does matter. But my point that I'm trying to do is when you're trying to do the composition of f of g of x, which is, again, basically f of g of x, right? You're basically plugging the g of x function into the fx function. So to identify this domain, what you need to do is you need to find the intersection of two domains, g of x and f of g of x. Okay, so you basically just need to find the domain of g of x and f of g of x. So let me give you an example. I guess might as well just finish this off. Let's pretend g of x is the square root of x, and let's pretend f of x is 1 over x squared. All right, so the domain of g of x is going to be all numbers that are greater than or equal to 0, right? And for f of g of x, when you plug those in, when you plug that in, you're going to have 1 over square root of x squared, which equals 1 over x. So that's going to be all real numbers except for 0. So again, we're trying to find the intersection, right, of combining these two. Well, again, the values have to be greater than or equal to 0, but this one's basically saying all numbers that are in the domain are going to be from -infinity to 0 or 0 to infinity. Well, the only domain that's actually intersection, you'd have to graph these, I think would be better to see this, but you can see the domain here is just going to be from 0 to infinity. So that's just a really quick explanation for you, because again, guys, as I apologize, I have some enters to get in. Yes, well, if I can, I did a problem like it. So once my live stream's over with, just go back a little bit, and you can see I did a quadratic formula example right there. Sarah says, when will you be going live again? I plan on going live, guys, every Sunday evening. It's kind of happened to work out that way, roughly around 9 o'clock Eastern time for myself. I usually, every single time, I'm always posting on my community tab, as well as getting this live stream set up roughly around like 1 or 2 o'clock is usually my goal. So therefore, if you are just logging into YouTube on a Sunday afternoon, then you will see that there is hopefully an alert if you are, I'm assuming, subscribed or have, bell notifications. So therefore, then you're aware that I am going live that evening. And typically, guys, the only time I've missed my live streams have been when either I've been sick or my girls do not go to bed, and then everything gets delayed. However, I will let you guys know that I am going to go live again this week. I would probably say, let's see, Monday, Tuesday. Maybe I will have to go live this week. Probably won't be till like the end of the week. I'll go live because we're going to do our second quiz on trigonometry. So if you are interested in graphing sine, cosine, tangent, cosecant, secant, cotangent, as well as evaluating the inverse of trigonometric functions, that's what our quiz is on. So, so be a lookout. I'm not really sure when that's going to be, but I'll have grading and stuff like that. So usually I don't really let people know, but I tell you, hey, if you're subscribed, notifications, you'll be able to get that for you guys. So, all right, guys, I have to run, but I'll just kind of see. Seeing some of you guys laughing on Common Core is evil. Yes, I can only imagine. Yes, so I go live on Sundays, and then sometimes I fit in live streams during the week. So the domain is from 0 to infinity. Yes, Johnny, that is correct. All right. And guys, you know what? Math is always fluid. I mean, just keep on working hard, guys. A lot of times you get hard stuff, and just keep on doing what you can do. And like, yeah, sometimes, I mean, a lot of people come to my class and are like, oh, math was always easy. And then it's like, wow, pre-calculus. And it's like, yeah. You know, and then they go to calculus and it's like, wow, this is even more like, you know, so it's, you know, building up a lot of those skills, which is one of the things that I point out in my email, or I'm sorry, in my, you know, review that I'll have for you guys. You know, it's first like some tips, like work on practice problems, you know, like I'm happy a lot of you guys have joined on live stream. Like hopefully you've taken away some understanding in math from like watching me explain some of the concepts, and maybe you understood, maybe you didn't. But, you know, also I think that, I mean, if you're really going to get really proficient in mathematics, it just comes into practicing, working through a lot of these problems. So either way, guys, I have to go ahead and sign off. I do apologize for those of you that added in some questions at the end. Thank you so much though for joining me on the live stream. I really had a great time with you guys, and I look forward to seeing you on the next one. All right, cheers. Well, now it's not going to let me go off. There he goes. All right, see you guys.